Okay, the next trig, or the next integration techniques we're going to look at are when you have certain combinations of trig functions. So the first situation we're going to look at is if I've got sine to some power times cosine to some power. Okay, and certain rules that we're going to use when we have different powers here. So if m is even, so if I have an even power on my sine function and n is odd, what we're going to want to do here is pull out a cosine. So let's say I've got the integral of sine to the fourth times cosine cubed. Okay, I'm going to pull a cosine out. So I'm going to turn it into this sine to the fourth cosine squared. And I'm going to leave a cosine out here. This will eventually become our du. Alright, so what I'm going to do is I'm going to want to turn everything into sine. Because if I have everything in terms of sine, I'll have sine to some power, and then I'll have the derivative of sine over here. So I'll have a u to the power with a du. Okay, so in order to turn cosine squared into sine, this becomes 1 minus sine squared, because sine squared plus cosine squared equals 1. So I'd turn that into this, and then I'm going to distribute. So I'm going to get sine to the fourth x minus sine to the sixth x times cosine x dx. Okay, I can distribute this in so that each piece has its own du. So I'm kind of doing two integrals now. I've got sine to the fourth x cosine x dx minus the integral of sine to the sixth x cosine x dx. Now this really is u to the fourth du, and this is u to the sixth du. If I make u be sine of x, du would be cosine x dx, which I have there. And we just use power rule, so this would be 1/5 sine to the fifth x minus 1/7 sine to the seventh x plus constant of integration. If m is odd and n is even, pretty much the same thing, only this time I'm going to pull a sine out. Okay, so let's change and have sine cubed x cosine to the fourth x dx. I'm going to pull one of these sines out. Okay, turn the sines into cosines, so this would become 1 minus cosine squared. Distribute this cosine in and the sine. Okay, and then I'd have minus cosine to the sixth x dx. Oops, sine x. So now if u is cosine, du would be negative sine. So I need a negative. I'll just bring this negative inside here. I need to turn this into negative, so I'll have a negative outside and in to cancel each other out. Now that negative is part of my du, so I've got u to the fourth du, and I've got u to the sixth du. This one's negative, this one's positive, and then we'll just finish it off kind of the same way we did the other one. If they're both even, then what we're going to do is use the power reduction formulas. So these are cosine squared x equals is 1 plus cosine 2x over 2, and the sine squared x is 1 minus cosine 2x over 2. So we would turn these into this, and we might have to use repeated uses of these until we get down to something that we can integrate. So let's say we have sine to the fourth x cosine squared x dx. Well, I'm going to turn this, and we're going to reduce this power. So this would be sine squared squared. And sine squared is really 1 minus cosine 2x over 2. And this would become 1 plus cosine 2x over 2. I'm going to square this out, so I'd get 1 minus 2 cosine 2x plus cosine squared 2x. That all would be over 4, but I'm just going to pull the 1/4 out to the front. Since it'd be over 4, that's a 1/4 in front. And then this would all be multiplied by this guy. I'm going to pull this 2 out, so that makes this an 8. And this is 1 plus cosine 2x. And from this point, could distribute this all out. Or could do integration by parts, but that looks like it'd be messy. So I'm just going to multiply all this in. So I'd have 1 minus 2 cosine 2x plus cosine squared 2x. That's from distributing the 1. When I distribute this, I'm going to get plus cosine 2x minus 2 cosine squared 2x plus cosine cubed of 2x. Combine like terms. 1 minus cosine 2x plus cosine squared 2x plus cosine cubed 2x. Now I can start splitting my integral up and integrating each piece. So 1/8 this integral minus 1/8 this integral plus 1/8 this integral plus 1/8 this integral. This one is easy. This just becomes 1/8 x. This, all I need, this would become like cosine u. I just need a du, which would be 2, so I'm going to have another. If I put a 2 in here, I need a 1/2 out here. So this would be minus 1/16. Integral of cosine is sine. This one I'm going to have to do power reduction again. So this would become 1 plus cosine 4x over 2. This one I'm going to pull out a cosine 2x and switch the other one into 1 minus sine squared. So it would be 1 minus sine squared 2x with a cosine 2x dx hanging on there. Cosine 2x, yeah. So we're done with these parts. We'll just remember to bring those down at the end. This one now is kind of straightforward. Let's pull the 2 out, so this becomes 1/16. Integral of 1, which becomes just x. I'm going to need, so I've got the 2 out. I need a du, so I need a 4 to integrate this part. So that's 1/4 again, so 16 times 4, 64. So this would be plus 1/64. sine of 4x. This one, I'm going to be able to integrate cosine of 2x just like I did up here. So I get the same thing, actually, and since I'm adding it, that's going to cancel this one out. Okay, because I'd have cosine 2x just like I had up here. So that's actually going to get rid of this one. And then the other part that I'll have is of sine squared 2x cosine 2x dx, which is u squared du. So pull this minus out. This is minus 1/8. Actually, my du would be, I'm going to need a 2, so that's going to turn this into 1/16. So let me write this one down below and show you what I'm doing for this last one. I got 1/8, 1 minus sine squared 2x cosine 2x dx. Okay, because one of these cosines I pulled out, the other two turned into 1 minus sine squared. So when I distribute this in, I get cosine 2x dx minus the integral of sine squared 2x cosine 2x dx. This one is the same thing that I had up here, so that's why it canceled. So this one canceled with that one. This one now, I've got, if u is sine squared, it's just sine of 2x, du would be 2 cosine 2x, okay? Derivative of sine is cosine, derivative of the inside part is 2. So I need another 1/2 out here. So that makes this negative 1/16 integral of u squared du. So this becomes 1/3. So that would make this negative 1, let's see, times 3 would be a 48. Then it'd be sine cubed of 2x. So I'd have this and these and this plus c. Okay, so that's when you have sine and cosine. I'll make a separate video for the other special trig rules for section 8.3.